glad to have you back. Alright, so we're good? Alright, what must be true to prove differentiability? What did we just say were the two things that had to be true? Has to be continuous. Did we already prove that? Yes. And the limit of the derivatives from both sides of that value have to be what? Equal to each other. So that means we're probably going to have to find the what of this function? The derivative of it. So let's do that before we get started. What's g prime of x going to equal? How do I do that? Good job, Alejandro. Just find the derivative of each one. You're a genius. Okay? So, find the derivative of the top one. What's that one going to be? Half x plus 1 to the negative half. Okay? What's the derivative of the bottom one? Negative 1. You can write the domain if you want to, but we don't really need it. The domain will be the same as the one up there. Are we okay? This one's actually times 1 also, right? But the times 1 doesn't affect it, so most of the time we don't write it. But it's good practice so you can remember that you need to get the derivative of what was inside. Okay? Alright, good. So let's write down the steps. So the first step was to say that it was continuous. So we already proved it. So g of x is continuous at x equals what? 3. Okay? If that was the only question that was asked, this one right here, they didn't ask this before it, you would have to show all of this in that first step. Okay? Cool? Alright, the second thing we said was that the limit of the derivatives. So the limit, I keep putting that. The limit of g prime of x as x approaches what? 3 from the left. What would that equal? Where am I going to put the 3? Into which one of these two? The first one, right? So that would be 1 divided by 2 square root of 3 plus 1. So that gives me 2 times 2 is 1 over 4. Is everybody okay? Okay that I went from this to this? You didn't freak out? No? Alright. The other limit is as we approach 3 from the right for the derivative. So what would that end up being? Negative 1. So what happened? They're not equal, right? What's the slope approaching from the left? 1/4. What's the slope approaching from the right? Negative 1. Does that make sense? If I look at the graph, does this seem to be like a very small slope compared to this completely negative 1 slope right there? Yes, as I get closer and closer, will they ever be the same? This one's not changing, right? So, no. So that's why it's not differential. That's why it's creating that cusp. So let's write out the justification. Since the limit of g prime of x as x approaches 3 from the left does not equal the limit of g prime of x as x approaches 3 from the right, g of x is not differentiable at x equals. There's not too many of these questions on the AP test, but this does come out in the free response every now and then. It doesn't come out directly like this, but the underlying concepts are the same. I'll show you some that will come out on the AP test, like the ones in the back. Those 2 examples that are next. Okay? And that would be like one part of the free response. That would be like part A. And then there's B, C, D. Cool? Now you gotta do stuff with everything that you got. We okay? Wanna try another one? Before we get to the fun ones? Alright, so let me give you your assignment. If you choose to. Makes you rethink it?
Yeah.
Why?
They did it 9 balls, yeah.
Our life is full of choices.
You can't play unless you do it.
Oh, 9 balls, but 9 balls.
Put away your phone, Ashley. Stop playing pool. Pay attention, this is a geometry class.
Never get it, I think JD Josh. When Josh.
Combine work and function questions.
Okay, you're gonna pick up tomorrow. You don't have any.
I have it already.
This is the one we just got.
Just give me one.
Oh yeah, I forgot. I'm sorry. I gave you both of them already. I'll get them. I'll get it later. Okay. I just already gave it to you guys today.
Really?
All right. So
That's good.
you want more homework every day? Sorry. All right. So let's look at number 12 on the back.
I'm good for that class, no doubt.
I understand this page.
So what is number 12 asking? Determine if this function is what?
Differentiable.
Differentiable. What two things must be true for me to mathematically prove that it's differentiable? Must be continuous. Okay, so let's do that. Gotta check for continuity. You ready? So on the left hand side, we're gonna check for continuity. Check for continuity first. Here we go. First thing is the function must be defined. We're checking for a differentiability at 2, so we're checking for continuity at 2. So f of 2, can we plug it in and get an answer? Yes, into the top equation, and that would be 4 plus 2, right? Is 6. Yes? Second thing is the limits. So the limit of the function as we approach 2 from the left, what does that equal? It's the one we just did, right? Which is 6. Do the one from the right hand side before you write the notation. So plug in the 2 there. What's 4 times 2? 8. 8 take away 2? Also 6. So I'm just going to put here another equal sign, and I'm going to write the other limit notation. You understand? Save myself some time and not have to write the whole thing. The third step is to show that those two values are equal, right? So f of 2 is equal to the limit of the function as x approaches 2. They were both 6, right? So we're good. It's continuous, right? Therefore, f of x is continuous at x equals 2. What's the second part? So check limits of the derivative, right? So that means I need to know the what first? The derivative. So let's find the derivative up here real quick. What's going to be my derivative equations? What's the derivative of the top one? 2x. What's the derivative of the bottom one? 4. Okay, so now let's check our two limits. So the limit of the derivative as we approach 2 from the left has to equal the limit of the derivative as we approach 2 from the right. What's the limit of the derivative as we approach 2 from the left? That's the top one, right? 2 times 2? 4. Has to equal the limit from the right. What's the limit from the right? 4. Are they equal? Yes. So we can say, therefore, f of x is differentiable at x equals 2. Because I showed the first step, I showed the second step, I can say that it is differential. You understand? Papitas? Not hard, right? Okay, we needed to know how to find derivatives before I could do problems like this, right? Are we good? Can we go to the more complex problems? Yeah? The ones where we're working with variables rather than numbers? Oh, how fun, right? Still the same idea. Let's go back to the notes and do these last two examples, and I promise we'll be done, okay? Yeah? So for what values of k and m will the function below be both continuous and differentiable at 3? So here I'm trying to find, Valeria, the two numbers that I can plug in for k and m that will force this equation to be continuous and differentiable. Okay? So I need to work it out and figure that out. So first, let me try for continuity, right? If I want it to be continuous, what has to be true? So if h of x is continuous at x equals 3, what has to be true? It has to be defined. So is it defined? Yes, because it can be equal to 3. I can plug it in and get a number. Okay? Do you want to write that down? We can. We don't necessarily have to. That's not really the important part here. The really important part is the second step, which is what else has to be true? The limit of the function as we approach 3 from the left has to equal the limit of the function as we approach 3 from the right. So let's check that. What would be the limit from the left of 3? What am I going to do with this 3? Plug it in for what letters, Gabriel? For the x's only, right? So I'm going to come to this top equation, put the 3 in there. What's 3 plus 1? 4. The square root of 4? 2. So that gives me 2k. Okay? Not okay, 2k. Okay? Alright. The limit from the right of 3. We're going to get that 3 and put it in for the x. So what do I get there? 3m plus 2. What is it? That's weird. So how do I get k and m? How many variables do I have? 2, but I only have one equation. Okay? So you need to have the same number of equations as the same number of variables in order for you to figure out each single variable. So I don't have 2 equations, so I can't find 2 variables. You understand? So I'm going to stop there because there's nothing else I can do. And then I'm going to check the other part. What else do I want this function to be? Differentiable, right? So if I want it to be differentiable, at x equals 3, what else has to be true? Not just the continuity part, but what else would have to be true? The limit of the derivatives, right? Have to be equal to each other. Maybe this will give me another equation. What do you think? So probably give me another equation, and then maybe I could use both of them together. You remember doing stuff like that in Algebra 2? They called it a system of equations. Yeah? Remember? Okay, cool. So let's see. In order to do that, I first need my what? My derivatives, equivalence. Let's get it. What's h prime of x? That's easy, sir. So this will be x plus 1 to the what? 1/2. K is a number, right? Okay, so remember that it's a number. So it would be that 1/2, right? Times k times x plus 1 to the negative half, because we're taking away 1, times the derivative of the inside, which is just 1. How about the derivative of the bottom part? M. Very good, please. If it was 5x, the derivative of that would just be 5, right? Okay. So now let's find the limit. So now we're going to plug in the 3's for the x's in those two equations. Okay, so if I put the 3 there, right? That's gonna give me k on the top, right? Divided by 2 times the square root of 3 plus 1, which is k over 4. Can I put the 3 into the second equation anywhere? No, because there's no what? X. So that means that k over 4 is just equal to m. So now I have two equations that are using the same two variables, and they're involved in the same problem, so that means I can relate them to each other. They're in the same system. Okay, so how can I use this one in that one to solve for one variable and then the other? We could put k over 4 into m. Oh, look, that's going to give me fractions. I can put k equals 4m. Oh, so times 4 here. Good job. So now I can get this guy right here, right? And plug him in for k. So now I have 2 times 4m is equal to 3m plus 2. So now do you see that I have one equation that has one variable, so I can solve for it. So that gives me what?